Okay, hello everyone. Thank you very much for being here, and especially thank you for sticking to not only the very end of the conference, the end of the last day, and for choosing to come to this session. Lay back, relax, and allow me to tell you the story of how we go from code to cluster in my organization. My name is Andrada, and for the past 5 years, I've been working with ING Hubs Romania as a DevOps engineer. To clear a bit things up, what is ING Hubs Romania? We are part of the broader Dutch ING group, which is a global bank with a strong European base. The hub in Romania where I work at delivers a solution in software development, data management, compliance, non-financial risk management to other hubs and to other units of ING worldwide. I'm not going to tell you about that. I'm going to tell you about the pipeline. The agenda for the next half hour is going to look like this. I'm going to tell you about the context, what was happening in the organization around 5 years ago and how we got here. We're going to look at the solution layout, its building blocks and how it actually looks like. I'm going to tell you about some of the features we implement and some of the ones we built. Second to last, we're going to look a bit at the risks and how we dealt with them. And finally, you will see a recorded demo of the pipeline because I lost my faith in the demo gods. I'm not taking any chances. Hopefully, we're going to have time for a few Q&A, for a few questions at the very end. The context. It was 2019 when inside our organization, a technology shift was happening. The stack consisting of GitLab, Jenkins, TFS, and Ansible Tower was being replaced with Azure DevOps and OpenShift. Due to this, applications were being migrated from VMs to containers. Before this, engineers would create the pipelines however they saw fit, but they were respecting some guidelines and policies. A need for a more standard deployment approach was identified. To take advantage of this, a small group of engineers collaborated with the developers of a Tier 0 application from ING to create a POC. The idea to create the Kingsroad pipeline was born then. If we were successful with a very complex application like that one, we would be successful with all of them. The next year in 2020, the Tier 0 application went live in production in ING's private cloud using the Kingsroad pipeline. They became our main promoter, and soon other applications and teams in our department were showing interest. In 2021, the word spread to other countries in ING as well. We soon got to markets like Spain, Poland, Romania, and the Philippines. Similar initiatives were happening at the same time in those countries, but we were the first ones to go live in production. The next year, we kept growing organically. In the organization, however, the number of deployments was being reduced to focus more on the resilience and reliability of how those deployments were happening. But those were things the Kingsroad pipeline was already offering. This was a catalyst that allowed us to have a much bigger growth in the following years. In 2023, the pipeline became mandatory in our tribe. This allowed us to grow to 1,000 onboarded applications the next year. Sorry, wrong button. And finally, we are in 2025 when we started refactoring the solution to employ a more global approach. So what is the Kingsroad pipeline? It's a set of templates developed for Azure DevOps. Its goal is to automate the CI/CD process of applications using the ING internal SDK and the service mesh. To give you a bit of a perspective, there are a couple thousand applications in the service mesh. I have a nice chart where I'll quickly show you how we grew in the last 5 years. Started with 1 consumer in 2020, around 30 in 2021. We reached over 100 the next year. 400 in 2023, we skyrocketed to 1,200 in 2024, and finally today we stand at around 1,600 onboarded applications. The solution layout. The actual flow is the standard one. We build, deploy, and test. For building, the pipeline is tailored around Spring Boot applications. To use the build templates, you must package your application into a fat jar. We then rely on Maven to do the heavy lifting and actually build the application. Additional to this, we need the configuration files in a special format which we call the configuration zips. We have the next slide is dedicated to those files. After this, we're building the Docker image. We start from an approved and vulnerability-free base image from the infrastructure team, inject the jar there, scan it again, of course, and push it to an Azure Container Registry. The deploy template is plug and play. It can be used with any kind of application as long as you provide the correct input. A vulnerability-free Docker image and your configuration files. Here we employ a continuous delivery approach rather than a continuous deployment one, so we still have some manual validations in place. Lastly, the test templates are similar to the build ones. The tests must be packaged into a fat jar. They are then released in OpenShift to run, and the results are back in the pipeline using a feedback loop. Our developers have access to an additional testing tool, which we call the Conformance Test Kit. This is an internal tool which can be run both in the pipeline and locally, and it can mimic the production environment, so developers can better test their features. It can benchmark your application, run performance tests, and some other features. The configuration zips. This is a very important object from our pipeline setup. We use Helm to do the deployments in OpenShift. This allowed us to impose a configuration standard that is easy for the consumers to create and for us to use. So as a consumer, you have to provide the following: a zip archive containing a directory for storing certificates and key stores, a directory for storing application configuration files, and the values YAML file where you have some flags available to configure. To complement, the Kingsroad pipeline offers you the templates directory, which contain every template for the Kubernetes objects you're going to need for your release, and the chart information YAML, of course. Because we use Helm, we can deploy and control in isolation the application release, common namespace objects, certificate release, cron jobs. Sorry, this effect was sped up when I last rehearsed this. Monitoring and auto-scaling releases. Two deployment strategies are available for our users. The first one is rolling update. This allows the user to roll out a new version alongside the old one, switch the traffic to the new, and clean up the old. The second one is the canary release. This is the default strategy that we impose to our users. This strategy makes use of a baseline, which is a fresh instance of your old version, and the canary, an instance with the new version. During the release process, traffic is split between the old version, the baseline, and the canary. We do this to assess the behavior of the new version compared to a fresh replica of the old one. This ensures a clean slate for teams to properly compare the metrics, performance, and other indicators of how the new version behaves. Let's say once you have the technical go live, the canary is scaled up, the baseline is cleaned up, and the rest of the traffic is switched from the old version to the canary. Lastly, our canary is promoted to live, to running version, and the old version is scaled down. Some of the features we have and we implement. Part of the pipeline, we have configurable features, default features and configurable ones. Looking at the default right now, at Kubernetes deployment object level, we enforce the deployment strategy on rolling update with a max unavailable of 0, so we don't have any downtime. We make sure the affinity rules are in place to accommodate the HA configuration of ING's private cloud. We also make sure you have all the needed network policies to actually connect to the service mesh. And lastly, we also control the image pool policy. As a user, you can configure your ports, liveness, readiness, and startup probes. You can use cron jobs, multiple containers. You can use the HorizontalPodAustoscaler and the custom object, which we call the QuotaAutoscaler. Has anyone from you heard of the QuotaAutoscaler CRD? Okay, perfect. Let me tell you a bit about it. Because this is an open source custom resource definition created by ING. Its purpose is to automate the flow that engineering teams had to perform, which was the scaling of the namespace. So in the past, to scale your namespace, you had to go to a resource management portal, follow some steps, and wait for the namespace to be actually scaled up. If you needed to scale down, you needed to do that all over again. With the QuotaAutoscaler, you simply add a configuration in your pipeline. This is how you do it for the Kingsroad pipeline in your values file, and this gets deployed in OpenShift. This is how the actual manifest looks like, the one that gets applied in OpenShift. Based on memory and CPU utilization, your namespace is scaled up or down. Other cool solutions we implement part of CNCF ecosystem. Prometheus monitoring, of course, because we all want observability and metrics and we want to see them in the Grafana dashboards. Native Helm rollback because we want our pipeline to be reliable. Automatic certificate management with CertManager because we are tired of approving manually all of our certificate requests. Open policy agent to run policy as code because we don't like doing them in the GUI. And lastly, Ansible releases because we also have consumers who are still on virtual machines for one reason or another. We couldn't have gotten to 1,600 onboarded applications without supporting some custom use cases. Let me tell you a bit about some of the features we built for those users. The first one we call auto-patching. So every 30 days, the application image needs to be renewed, even if there are no real application updates. Of course, our engineers reported this activity as toil. To ease their work, we developed this feature which does exactly that. Redeploys your fat jar using a brand new base image and ships it to production. The next one is the configuration-only deployment. So incidents might happen because of configuration changes, and most times the same incidents can be mitigated by another configuration change. To do this, going through the traditional flow takes a lot more time. So we created this feature that allows you to rebuild only the configuration zips, takes your latest production image, and ships everything to prod. Application bundles. Teams can build and deploy applications of different flavors and different configurations and the same namespace at the same time. A standard playbook for our Ansible users they can use as a starter point for when they want to start using the Kingsroad. And lastly, a custom Docker base image. As I mentioned, our goal is to be used by every application inside the service mesh. But the beauty of being in a global organization is that not everyone is using the service mesh, and not everyone is using Java. So to broaden even more our sites, we made available the usage of a custom Docker base image for applications which are non-Java. Almost to the end, I'm going to tell you about the risks, some of them. I would define our organization as one with a very strong risk culture. Staying in control of the risks and threats your own applications can create is essential for a reliable environment. We contribute to this by enabling several checks and validations in the pipeline with Python. We make sure your application resources and limits are equal, because we don't want Kubernetes killing off your pods because they're consuming too much memory. We make sure the deployment branch you use is a stable one, a main or a release one. We also make sure that the last merge on that stable branch is approved by a secure code reviewer. And lastly, we validate that the base image you're using is vulnerability-free and approved by the infrastructure team. Because the happy flow isn't always the case, deviations might appear. Let's say that you're in a major incident, the SLA is almost breached, and you have to deploy from your bug fix branch. But that's not a stable branch, so your pipeline will fail. For this, we enable the break the glass mechanism. It's a simple manual validation where you give a justification for your deviation. And of course, all of your stakeholders get informed, and then you'll have some emails to respond to. We don't only use Python to do checks and validations. As I mentioned before, we also use Open Policy Agent. Using Python, we created our own assertion framework to enable us to correctly run policies written in Rego natively in the pipeline. With OPA, we are verifying the internal SDK version you use, so it's still supported by our team, by the team that develops it, sorry. We also check the Kingsroad version you use, because we also have a strict support window. And lastly, we look at your application configuration files. We expect teams to use certain properties to mitigate possible security risks. And lastly, it's demo time. Cool. I'll start by showing you how the actual pipeline looks like. We're going to start at the top with the checkmarks code and the dependency scan. OK, now it's fine. Starting at the top with the checkmarks code and dependency scan. This is one of the tools we use for scanning our code. In my case, it failed. By the way, if the colors looked messed up, it's because I inverted them. I know that some of the other speakers who use the dark mode, it wasn't really visible on this, so the colors are inverted. That's why it looks a bit shady. In my case, this stage failed because I'm using a mock application. I don't really care about my dependencies right now. It's just for the sake of the demo. The next stage I will show you is the building and publishing one. This is the one that actually builds the fat jar, your application, and then it publishes it in the pipeline so it can be later consumed by other stages. The one after that is the one that builds the Docker image, or in my case, the Docker images. I'm also releasing a cron job, so I need an additional image for that. After everything is scanned, it's going to be pushed into an Azure Container Registry. And lastly, the big bad wolf from this pipeline is the deployment stage. I called it like that because it has 28 jobs. I know it looks intimidating and a lot, but they all are very valuable. So we start by looking in the namespace to see what exactly we have there, at what version we're running, what components we have. Then we do the canary deployment of the baseline with the old version and the canary with the new version. That usually takes the longest. And then we start switching the traffic from your old version to the baseline and the canary. This is where also the canary analysis done by the teams should happen. Let's assume that this was done, all of the routings were approved. And once we reach that technical go live I told you about before, we are scaling up the canary and cleaning up the baseline. Okay. After this, I'm switching the rest of the traffic from my old version to the canary one. And in the very end, I make sure that I pass a very important gate, which in this case is the blue one with canary duration. This is a gate that, if this were a production pipeline, would enable break the glass. This validates how long I stayed in the canary state, so how long I did my analysis. Because this is test, it passed, I don't care about it right now, but for production, it's very important that teams perform this analysis as thoroughly as possible. At the end, once this gate is also passed, I'm scaling down my old version, and the pipeline is on green. Or purple in this case. This is how my YAML looks like. This is with the minimal amount of parameters. Of course, you can add many, many more, but this is the minimum required for it to work. The first stage here is the build-up container. This is actually a wrapper template around the first three stages I showed you initially. So the checkmarks one, the build and publish, and the Docker build and scan. We did this so teams don't have to call 3 templates with similar parameters. They just have to call one. And the second template is the one that actually does the deployment. I'm giving it all the needed parameters. This block right here is the one where I'm describing the environment where I want to do the deployment. I'm telling it I want to go to test. I'm telling it the data center where I want to go, giving it the service connection, Azure subscription. An important note here, I'm telling it to start with 2 replicas of my deployment. And this block right here, the release components, is telling the pipeline which Helm component it should release. It should deploy the application, the certificate, maintenance, monitoring. In this pipeline, I deployed everything, all of them. Now we're going to go to the terminal to show you a bit more about that cool object, especially the QuotaAutoscaler. So before I started my pipeline, I set a watch on my resource quota. The resource quota tells the namespace the hard limits of the namespace. And the QuotaAutoscaler actions exactly on this object. I will soon, 1 second. Yeah, it looks at the limits of the CPU and memory, but for the sake of simplicity, we're only going to talk about the memory limits. In the very beginning, I had 0 consumption. The QuotaAutoscaler is the first one that gets deployed. Then the deployment starts rolling out. So in the beginning, my namespace was empty. I had 0 consumption. Because the QuotaAutoscaler saw that, initially it started scaling down the namespace. You can see that in the beginning I had 4 gigabytes, and a bit down I have 2 gigabytes. But my deployment started rolling out, so I started to consume resources. So I am at 1 out of 2 gigabytes, going a bit down, 2 out of 2, I reached my maximum, so the QuotaAutoscaler kicked in again and scaled the namespace up. And this keeps happening until, hopefully, actually not hopefully, I reach the hard limit that I defined inside the Autoscaler object. Yeah, I see 4 out of 4, 3 out of 5, 4 out of 5, sorry. Okay. The next thing I'm going to show you are some of the events of how we used CertManager to request our certificates. I cannot show you how the certificate looks like for obvious reasons, but we can quickly look at those events. So for the certificate request, I can see that my certificate request has been approved by CertManager. Okay. The order has been created, a bit down, and my certificate has been successfully fetched from the issuer. Looking at the events for the certificate, I see that the secret does not exist yet, and a few seconds later, a few more seconds later, the certificate has been successfully issued. If I do a get on the secret, it's right there. I also already know that this happened successfully because my pipeline didn't fail, because obviously without the certificate, my application will not start. Now, this is how one of the most important bit of configuration from the QuotaAutoscaler looks like. This is where I'm defining the behavior. So the QuotaAutoscaler, as I said, scales the namespace down based on the CPU and a logical and memory utilization. So if the CPU and memory utilization are above 65%, the namespace is scaled up. If they are below 85%, sorry, I'm nervous. It's the last presentation, I know. I'm nervous, sorry. So it scales up if the usage is above 85 and down if the usage is below 65, with a maximum threshold of 15 gigabytes of memory and a minimal one of 2 gigabytes. I also have my HorizontalPodAustoscaler. How many of you have used this object in your setups? Okay, then we're gonna skip to that because you know what's happening. How many of you understood the algorithm? Because I still struggle to understand it. I still read the documentation and yeah. Okay. Last thing is how easy we can do rollback with the pipeline. In my case, I rolled back the maintenance release, meaning the cron job. It's here, it ran for around 33 seconds, doing validations to see what's on the namespace, doing the actual rollback. And if I go back to the terminal, Andrada from the demo, please go back to the terminal. Yeah, and if I do a Helm history, I see that I am at revision 3, which is actually a rollback to revision 1. Okay. Wrapping things up, so the Kingsroad pipeline is a set of templates we wrote to automate the CI/CD process of applications inside our organization, which use the ANG internal SDK and the service mesh. We provide build, release, and test templates written for Azure DevOps. The build is tailored for Spring Boot application, the release is plug and play, and you can use it with any kind of application as long as you provide the correct input, the Docker image and the configuration zips. You can make the release by using rolling update deployment strategies and canary release. We also implement some CNCF projects like Prometheus, CertManager, Helm, Open Policy Agent, but we also built some in-house features for our consumers. Automatic image patching, configuration-only updates, bundle deployments, and the custom Docker file. As I said at the beginning, my small challenge for you is that tomorrow when you open your laptops, think about, can you implement such a solution in your organization? Thank you for your attention. Any questions? Yeah, yeah. I'll repeat it so everyone can hear. So how can a team onboard to use the pipeline? We have a separate repository with a JSON file where you describe some of your configuration and some of your stakeholders that should get informed. And then you just reference the templates from our central repository, and that's it. It's a very good question for which I don't have the answer because we were not the ones responsible for choosing it. We are making the best out of it. So far, so good. Yeah? Mm-hmm. Yeah. So the question is, how do we allow teams to add additional steps, stages, jobs inside the pipeline, and how do we govern that? Yes, we do allow. The stages are not tightly coupled to one another because otherwise people wouldn't be able to use only the deploy part or only the build. For some of them, you can add pre and post jobs. You can add stages between them. We have no governance on them. If you add them, it's your responsibility what happens to them and what is their output and input. And I think one more question, if anyone else wants. Okay. Thank you so much for being here. Hope you had a nice conference, and see you next year, maybe.